Hello, I'm Lou Grice, VP of Digitalization and Government Relations at Phoenix Contact's U.S. headquarters in Middletown, Pennsylvania. Welcome to our panel discussion. Today we're in store for a really interesting conversation where we'll dive into the topic of smart manufacturing in the USA. So, among all the fluctuations happening in the global manufacturing space, there's a renewed sense that we're on the verge of a significant resurgence of manufacturing in the United States. In brief, it's been said that America is on the cusp of a great manufacturing renaissance. This is a unique moment in history when industry leaders and institutes and the academy are all aligned with government policy and legislation and funding and a vision of what makes American society strong and its economy resilient through USA-based manufacturing. So the question becomes, what are we doing to fulfill this great opportunity, or how might we squander it? Smart manufacturing offers an extraordinary means and challenge to necessary evolution of U.S. manufacturing. So in today's panel, we'll discuss the intersection of technology, the workforce, leadership mindset, and governmental support aimed at realizing a prosperous and sustainable future, a future empowered through smart manufacturing. And joining me today are some esteemed guests that will help us explore today's topic. At the far side over there, Mr. Ira Sharp, who is our U.S. Director of Product Marketing and Automation. Next to him is Dave Skelton, our Vice President and General Manager of Phoenix Contact U.S.'s Development and Manufacturing. Of course, Jack Nalig, our President of Phoenix Contact USA, and our very special guest, Mr. John Dyck, who is CEO of the Clean Energy and Smart Manufacturing Innovation Institute, or SESMII for short. John, let's start with you with a brief comment, if you would. You know, as our special guest, if you take a moment to bring us up to speed on SESMII, you know, its mission, a little on the different approaches and efforts SESMII is taking to fulfill its mission, how SESMII relates to the concept of a fourth industrial revolution, or Industry 4.0 for short.
Yeah, thanks for having me. It's truly an honor to be here with you all today. SESMII is a government-funded, funded by the Department of Energy, consortia. We're a private-public partnership focused on accelerating the democratization of smart manufacturing. It's really working with the brightest and the most forward-looking thinkers from every part of this ecosystem to advance the state-of-the-art of what smart manufacturing looks like. And fundamentally, it's got to look simpler, and it's got to be less costly in the future. And that's really what our investment and what our mandate from the federal government is all about. So convening an ecosystem to focus on the democratization, meaning reducing cost and complexity around technology and how we can engage in and drive innovation that reduces the cost and complexity of technology. Next is knowledge, workforce development, education. How can we raise the sort of level of education and awareness across this entire ecosystem? And the last of the three pillars is around how can we bring this ecosystem together to focus on more collaborative and more effective ways of engaging versus the sort of legacy proprietary approach that most of the technology providers in this space would be characterized as. And so that's really the core focus of SESMII, to convene this ecosystem, convene the forward-looking organizations as an ecosystem to accelerate the way we cross this digital divide together.
That's excellent. So just a few weeks ago at IMTS, week of September 12th, they did talk about a manufacturing renaissance, you know, for the United States of America. So John, I know you were there. I'll pose this question to you first. Why now? I mean, you know, what's changed, and where does government policy and support fit in this whole picture?
Yeah, I think as difficult as the pandemic was for all of us, and some more than others, it really underscored the dramatic sort of base assumptions, the evolution in what it turns out are base assumptions around what a global supply chain and manufacturing supply chain looks like. And the fact that over the last 3 decades we've refined and leaned out and created a manufacturing supply chain based on ideal geopolitical and socioeconomic and really fundamentally even the cost of energy. And And the pandemic underscored how fragile that entire supply chain and ecosystem really is. And so I think a lot of folks have grown used to the idea of just-in-time supply chain strategy based on just-in-time, and not to be cute about it, but I think we are fundamentally rethinking our global manufacturing supply chain around just-in-case now instead of just-in-time. And so there's been an enormous recognition that by the manufacturers here in this country that have in many cases kind of offshored much of what they do, including the knowledge behind how they develop and produce product, underscored for them how important it is to perhaps reshore or right-size operations in key parts of the world where perhaps they've gone a little too far in light of these new dynamics or realities, gone too far in perhaps outsourcing their manufacturing capabilities. So I think that's been a fundamental driver for helping manufacturers across this country really understand we don't live in a perfect world, and perhaps we need to rethink how we put our manufacturing supply chains together.
And it seems to have shaken the foundations of not just manufacturing industry, but government as well, right?
Yeah, there's clearly a recognition across every segment of this, both federal and state governments and policymakers, and all of the organizations around them, including academia, to recognize we have to change the way we're structured. We have to change the way we enable the talent supply, all the way to the incentives for manufacturers to come back here to the U.S. And so, yeah, it's across the board. It's unanimous. It's a very unique time in our manufacturing history.
It's a great intersection of trends too, right? I mean, the climate and sustainability, they've gathered political and legislative momentum over time. Now these concerns are all intersecting with manufacturing as well. So, you know, how important is smart manufacturing for responding to the new sustainability trend?
Yeah, so I think, ironically, manufacturers have been working towards the sort of outcomes of sustainability and the new, relatively new emphasis on ESG in indirect ways for many, many years. I think the real opportunity now is to number one, make it more of a strategic priority, which it has become. This administration has clearly made sustainability and obviously carbon footprint, greenhouse gas emissions, a significant priority, climate change. All of these social challenges have become much, much more visible, and of course that drives strategy and that drives investment. And so the idea that manufacturing, and specifically smart manufacturing, can intersect with each one of those societal and global issues, challenges, opportunities is I think a really foundational component of how we collectively think about this, right? The idea that a more effective, less wasteful manufacturing operation and enterprise and supply chain can directly impact our carbon footprint, our greenhouse gas emissions. All of these strategic objectives is something we have to get much, much better at work articulating and defining. But I think that's the opportunity in front of us.
Excellent. And I'll give you one more here, John, because you mentioned it seems to be another major trend, which is this reshoring trend, right? So it seems to be major. It's accelerating for several reasons: global supply chain management, geopolitical issues, associated risk management. What role do you think smart manufacturing has to play in the reshoring trend?
Yeah, obviously the significant challenges in U.S. manufacturing that drove offshoring in the first place are still here. The cost of goods, the cost of energy, the cost of labor, those are relatively, those are as significant today as they were over the past 2 decades as we've been kind of on this trend. And so I think smart manufacturing really represents the idea of reducing cost and complexity of manufacturing operations, of the infrastructure and the systems and the digitization capabilities that are so vital to smart manufacturing, is how we get to the point where we have better equipped and more engaged workers, and we have more capable problem solvers in the baseline workforce than we do today. That's how we get to a more digital operation and a workforce that's engaged in solving problems and reducing costs and driving productivity. So without a significant emphasis on creating a more effective workforce, a more capable and a more engaged workforce, and reducing cost and taking out waste, we're going to struggle to bring those manufacturers back in a way that our economy can actually sustain.
Excellent. So when you look at the manufacturing space, I mean, there's a large variety of large manufacturers, right? Clearly that space is filled in sheer numbers by small and medium manufacturers. Some may be family owned, some may be a small division of a larger corporation, some may be startups, some in business for a long time. So Jack, let me ask you this question. Why should they be interested in smart manufacturing?
So it's a great question, Lou, because as you pointed out, the U.S. is, completely consumed by small and medium enterprises. That's how this economy runs. Yes, there are large global corporations there, and yes, they do a large footprint too, but this country has a mass of really great small and medium enterprise companies. But they've not had the access to the technology and systems that the large manufacturers have in the past. And there was kind of a key reason for that. There's several, but the key reason was, if you look at automation technologies a decade or so ago, the cost of those things and the cost to deploy those was very high. But today, with the maturity trend of all the automation that's going on in the world and Industry 4.0 and smart technologies, now the costs are dramatically lower. And they can enable small and medium manufacturers now where they couldn't enable them before. That's one. Number two is the second thing that can really help these small and medium manufacturers is if they actually look at their energy footprint and how they're consuming energy. Again, that wasn't even a possibility a decade or two ago. They didn't have an option, but today they do. And what the problem that we face for these small and medium manufacturers is there's a huge awareness gap. They just don't know what they don't know. They don't understand that it is possible to automate. They don't understand it's possible to run their own electricity. They hear about it and they just naturally assume it's too much money because a decade or two ago it was too much money. So I'll give you two examples, right? If you just think of a robot, an industrial robot, what comes to most people's minds are the big iron robots in automotive doing massive welding applications. Those robots could be $100,000, $200,000, $300,000. Today, there are cobots that simply act as value-added workers, and the cobots are as low cost as $25,000 to $50,000. So it's a massive change in paradigm on what a robot is. But those small and medium manufacturers don't know how to deploy those cobots, don't even know that it really exists that way. So there's a big awareness problem for them there. And then the second thing on energy, and we've gone down this path, we discovered through some trial and experimentation that here in Harrisburg, in our small and medium enterprise, we're a small manufacturer here, a few hundred employees, a great little manufacturing system, that we can generate our own electricity. About a decade ago, we put in about 1 megawatt of capstone microturbines, some natural gas-fired microturbines, and that went wonderfully. And then just last year, we deployed a 2nd megawatt of solar on our logistics center roofs. So today, we get about 1/3 of our electricity from the microturbines, about 1/3 of the electricity from our solar installation, and then still yet 1/3 from the grid when we need it, when the infamous, wind isn't blowing and the sun isn't shining problem, right? So, but what we discovered through that process is we could afford it because there's great government incentives and the maturation of those technologies have made those solutions low cost. we could afford it, and it now will help us with energy savings in the future. It's making our manufacturing footprint more competitive than it was before. So in the end, technology and costs of these things to enable a smart manufacturer used to be the problem or the barrier to SMEs utilizing it. Today, that's not the problem. Today is just simply, I think, their awareness of the possibilities that smart manufacturing can bring them, and then their ability then to put it into place.
So the gaps have been closed, but it's just the understanding that the gap's been closed.
Exactly.
I can approach this and what have you. Do you think there's, where would you say smart manufacturing is maybe catching fire right now for the small to medium manufacturer, Jeff?
So I would say in small equipment-based applications, so small point-based applications throughout a factory or a warehouse, there's a lot of great machine providers that have developed predetermined application spaces. For example, in our warehouse, at the end of the box creation process and packaging labeling, you then have a consolidation function where you might consolidate a lot of smaller boxes onto a pallet, and then you had to wrap it, and you have to give it to a shipper. Now there's these great, and which used to be a manual process of a stretch wrap, someone running around the pallet making it go. Now there's companies that make these wonderful little automated wrappers, and you just push a button, walk away, and it wraps it, and it stops at the end, and everything's great. So small prepackaged automation solutions are now available much more than they used to be, and I think that is probably the first place SMEs should start, and that's where we're seeing them head into that adoption. I'd say the growth could be on that energy footprint. I think many of them could start managing and deploying their own energy, and I think the whole cobot trend is going really well, but I think it could go faster and faster, and the small and medium manufacturers could take advantage of that more.
Oh, excellent. Very good. So, Dave, let's switch to you. So, you're the leader of our Phoenix Contact U.S. manufacturing. We've got now some experience in the implementation of smart manufacturing. Can you share with us some of the experience of Phoenix Contact with smart manufacturing, and what do we recognize as some of the most beneficial aspects of smart manufacturing?
Okay. Well, thank you, Lou. And yes, we have a facility in Bad Pyrmont, Germany. Okay, it's an electronics production facility that has implemented and has been operating as a smart production facility for a couple of years. They've found and have experienced over a 10% efficiency increase. And in turn, really, they've been able to find that they could actually take idea, to execution or to fruition 5 times faster after wrapping, digital production information, back to production employees that are already practicing lean and agile performance improvement processes. So if you think about this, you wrap this information around existing lean and agile process, and you create a turbocharger. And it's a turbocharger for production. That's what it is. So in Harrisburg, we have just begun this journey. And we have our Bad Pyrmont facility as a model and a template, and they also are as mentors. So they're working with us. Our facility here has electromechanical and electronic production. We have been practicing lean techniques for more than a decade, and we have been automating those process lines continuously during this time as it was financially viable. So when you look at us, we are a classic brownfield mid-sized manufacturer, as Jack brought up just a minute ago. And so, the way we are starting, is we have 3 pillars. The first pillar is shop floor management. The second pillar is data collection, and the third is analytics and visualization. The shop floor management is our lean process, and it's all process, because the process has to be right to start with, And what we've done is we've institutionalized it, made it a habit. We have Gemba walks and shop floor management meetings daily, using the data we get from our process. In turn, we have regular 5S events, we have continuous process improvement activities running. So this is now institutionalized. It's been almost a year since we started, and it's institutionalized. Then data collection. We started that in the beginning of June, really. We have 3 platforms of equipment we collect data from. We have an MES system, so we have an API, so that's one access to information. We also have new equipment primarily, but we have equipment that is connection enabled, primarily through OPC. And then we have our stranded workstations, all right, and machines, okay? And the approach we've taken there is completely non-invasive, all right? We take and we parallel wire, okay, usually in the control cabinet, the sensors that we want to collect. We wire them back to one of our existing products called PLC Next, all right? And that product acts as an MQTT gateway to our production network. So we have the information then. Now, we at this point in time are 30% on our way. So we have 30% of our workstations connected at this point. We will not have it completed until probably the second quarter of next year. And that's on the plan. We are doing this incrementally while we're doing our daily job. So that's part of the reason it takes a little bit of time. But it also is the opportunity that exists for other manufacturers at all. This can be incremental step by step. Our analytics and visualization is, it's in its very infancy, or it's not as mature. Now, I say that, and then we look out on the floor, and you'll see visualization stations at almost every workstation, every machine. we have it at the production, person's level, at the manufacturing engineer's level, machine by machine, process by process. Where we're going is to make this system-wide or enterprise-wide. And so to that end, we have implemented a digital twin. Today, that twin provides situational awareness. So by that I mean if you expect to see on the production floor a particular machine, you'll see it on this digital twin. You can go there and you can click on it and you'll see if it's on or off. You can see some basic data about that machine or that process. And then in addition to that, we have all of our KPIs by individual area, some by machine. And then we also have all of our process improvement programs posted and being updated live. So this is our first step. And in turn, we have, in this area, we have many more applications that we're working on and looking at. We've taken an approach that we pilot the application. Once we try to pilot quickly, we get our feedback. If it looks good, and good means 80% of the target that we had. It doesn't mean 100%. That's what we were getting ourselves wrapped up with before. So 80%, then we implement, we scale. Now, and if it doesn't, then we go back and spin again, or we put it aside for a while and look at it later. And so we have a number of those in process. Today, the big ones that we have right now are focused on in-process quality. We have another one on daily labor management, one on onboarding employees, another one on providing better maintenance, particularly on off-shift activities. So those are the apps we're running, and the other thing is we're also, our employees are bringing these apps up. They're excited, they have data, they see we're energized, so this just brings energy to the whole process improvement activity that we have. So the results we've seen, so we're still young, okay? But the first result we've seen that I really like to share is before, all of our process lines in our areas, people worked on them individually, I should say. So you focused on a process line, you focused on a production area. Because we're looking at the enterprise, we have created collaborative teams that are working on these applications. And these applications aren't that unique as you move across electromechanical or electronic or any other of the different production. Rather, they could have unique aspects, but there's a big common part. So with the piloting, we have a team of people pilot. Pilots go faster. When it comes to scaling, we can scale better because we now have experience and that team helps scale. So that's the approach we take into deploying the apps. And the big thing is this collaboration, this bringing together these resources. It's almost like adding people because you're focusing the energy around this. And then the other one is we can also collaborate speed, all right? And the example I like to give is when we do and start a process improvement, we typically start with our value stream map and we do a time study, all right? And then we go ahead and make the process changes and the process stabilizes, we do another time study. Well, once that is connected, that line is connected, those machines are connected, what happens is you don't need that time study to start with. I mean, you have the current state right now, all right? You make those changes. Typically you make the changes, you stabilize. It's a day or two before you do the second time study, right? And we're not talking days now. We're talking immediate. It's hours. You have the information. So that is speed. That is what we've never had prior to this. So for me, that's very exciting. So where I look at it now is we've just started our journey. We have, all right? But it does look like it's going to be a very exciting journey and very beneficial for our company and for all of our employees that are involved in it. So, thank you.
Mind if I comment on
Yeah,
that?
please. Yeah.
What I loved about that was, number one, that you understand deeply that this is a journey, and it's probably a never-ending journey. But perhaps even more, at least just as importantly, you created sort of the lean, continuous improvement idea, teams, people, process with the technology. There's, I would say, vastly more than 90% of manufacturers, including a lot of the biggest and best manufacturers, still view the two as distinct. Information and lean, or smart manufacturing and lean, as two distinct parts of the organization. And I think we will never become as competitive as we could be if we don't merge those two ideas, right? Some of the best manufacturers in this country, we're working with them right now to help them understand the value of leveraging technology versus holding it at bay. Because exactly for the reasons you brought up, the notion that you have a clear sense of the as-is state, you make whatever improvement you've identified, and you immediately understand whether that baseline changes or not.
Absolutely.
Right? And you improve from there. It's that baseline. And to finish that thought, in my 30-year career, without exception, I've seen this dramatic sort of epiphany that happens when with manually collected data that shows, you know, an OEE of 85% on average over the last 5 years. When you put in a data-driven system, that OEE is now 58%, and the first thing you do is you say, well, that system is broken, and we know our OEE is 85%, but the reality is it's been 55%. All these years, you have that additional capacity available to you, and you just right. So that's an enormous reality that we face.
It's fantastic.
Yeah, and Dave, I think, mentioned some really interesting points insofar as the transition that's happening. Is, you know, he mentioned the analytics, he mentioned the management, he mentioned the collaboration. Well, you know, machines aren't doing the analytics necessarily, or the management, or the collaboration to make this whole thing happen, right? There is change afoot, and that's, you know, human-driven, and it's hard, and what have you. It's worker-driven. You know, John, if you would expand on that a little, because, you know, changes are likely for workers in the movement towards smart manufacturing. Maybe call it, you know, let's call it Workforce 4.0 if you want. So, when it comes to the movement from Industry 3.0 to Industry 4.0 or smart manufacturing, you know, what changes in the ways leaders envision or empower their organization, do you think?
Yeah, I think this is perhaps the most important issue, right? How do we engage the labor force, the workforce more broadly in problem solving? And I think the reality is that over the last 30, 40 years of the third industrial revolution, we've created a level of technical debt, complexity, and cost that has made the data domain one of the experts. You can't, most manufacturers have struggled to provide their plant floor teams with the data they need to help them make better decisions. And particularly as you pointed out, Jack, for the small medium manufacturer, this idea of smart manufacturing has been inaccessible until recently. And so we've focused on the Workforce 4.0, as you called it, the worker of the future, in a couple of specific roles, but the unique thing that I think we're trying to drive towards is this notion of a citizen OT IT technologist. The average worker in a small medium manufacturing organization or a Fortune 1000 manufacturer, the average worker puts the most powerful tool in their day-to-day life, which is their iPhone or their Android device, in their pocket or in their locker when they walk out to the shop floor. But they know how to navigate, they know how to analyze, they know how to search, and if you give them the data in a secure and flexible way and give them the skills to engage in that manufacturing process to solve problems, that lights up a whole workforce in this country in ways that I think very few countries can emulate. So we're actually investing a tremendous amount in creating curriculum, sort of small bite-sized chunks of content and training material, hands-on, e-learning in different formats for that citizen OT, IT technologist, blending these domains together, forcing them, smashing them together in ways that we think will transform the workforce.
Excellent.
Lou, I'd like to jump
Please,
in.
John.
Let me
Please.
jump in, pile on that one. So on the Workforce 4.0 thing, this is again a thinking 10 or 20 years ago versus today. So the image in a lot of leaders' minds is that, oh my gosh, if we add a piece of automation, it's going to scare the people. They're not going to be able to work with it. This is going to be a problem. And in our experience here, it's exactly the opposite. And John made a great point that everybody's got that iPhone or Android in their pocket. So the workers of the world have been trained on digitalization without us doing anything because they live in those phones now. So they're actually very comfortable with automation. They just don't tell you about it. So they're quietly comfortable about it. Now to the example. In Dave's operation, he deployed a cobot. It was at the end of a production line that was highly automated. But it's now doing a packaging function. Okay? So we were all worried, oh gosh, we're going to put this cobot in there and it's going to scare the workers. They're going to be afraid that all their jobs are going to end, that kind of story. It was exactly the opposite. Once we deployed that cobot, the workers were so excited that they no longer had to do that crappy task of loading the boxes. They love it. They're proud of the cobot. They made it a co-worker. So our fear quickly went away, and the workers were excited we were making investments in automation to help them do their jobs better. That's what we're learning about it. So I think the workforce thing is of course a concern. Of course there'll be islands of concerns as you deploy more and more smart manufacturing in your facilities. But I think there's a pent-up demand by the workers to have this smart manufacturing system help them do their jobs better.
Yep. It's made technology more approachable for the average worker and what have you. And it's clear that new systems and technologies need to be ready to make smart manufacturing a reality. New approaches, new architectures, new ways of thinking seem to be driven by smart manufacturing. So let me address this one to you, Ira. What's the nature of these systems and technologies, do you think? What do they consist of, and how do open standards and automation fit in?
Yeah, it's a really important question because, we're talking a lot about data. We're talking a lot about getting information from a lot of systems that traditionally are going to be a lot of brownfield applications. So they're existing, they're working, there's operations that are happening, and extracting data or information from those systems is key. And there are a lot of new things that are coming out that can run in parallel, similar to what you were talking about, Dave. And maybe it could be literally wiring sensors in parallel to everything else, or connecting to existing control systems, or whatever it may be. But it's collecting data and then ultimately turning that data into information, so that information can be used for optimization within a machine, system, or process. And this is the IT/OT person that you were speaking about, John. And I think this is so critical to where this space is going, and it will drastically improve operations. It will drastically improve efficiencies. It'll drive down costs and improve sustainability efforts. It's all these key buzzwords all rolled together. And from an HR point of view, I think about this, and it's, Jack, what you were just saying. It's really providing more meaningful work towards the employees. So, what can do this? And it's devices that aren't invasive to the existing control systems. It's ones that can sit alongside the existing control systems, collect that data, and help bridge that gap between the IT and the OT space. And there are a lot of great technologies out there, including ones from Phoenix Contact, like the PLC Next platform, that lives in that space and does that function, serves that purpose. And then it's really a matter of collecting the data, transporting the data, using the data, and securing that information along the way.
So those data to information to operational understanding or knowledge ideas, it seems as if industries move in different phases, some lag, some lead. Do you have some insight, Ira, on maybe where it's beginning to catch fire, become more popular in certain industries, getting that job done?
Yeah, so when you look at industries, there are definitely some big movements that are happening, and I think maybe taking a step back from industry and looking at application, one of the most pressing applications that I've seen across different industries is energy management. And energy management is a hot one because if you're monitoring your energy usage on a machine, system, or process, it does a couple of things. Number one, from an overall operations perspective, you can look at how well is this machine performing? You know, are the bearings going bad? Why is all of a sudden my energy increasing more than it once was? Maybe I need to do some sort of maintenance. Maybe I need to know what's going on there. How often is it running? Why is it running when there's not an operator there? Or why is an operator there and it's not running? You know, these kinds of things. And then looking at it from an energy perspective of going to the sustainability pieces is you can't really measure your carbon footprint well without knowing how much a machine, system, or process is running. So how much energy is it actually costing? And this is becoming even more important in overall supply chain. So whether you're a manufacturer that is 3 steps removed from someone down the road, large manufacturers are getting very serious about sustainability, not only in their own operations, but in their supply chain operations as well. So having that energy monitoring is absolutely key. And so it's a key application. And then when you look at what's happening as far as a trend in this space, I think different industries are approaching this in different ways. And there's a group, it's the Open Process Automation Foundation, that is looking at this from a process standpoint. And what they're looking at is not necessarily just the energy piece, but it's looking at how we can evolve the space and look at different types of control systems. And one of the big trends that I've seen, and we're looking at it, I think, in the discrete manufacturing space as well, is the separation of hardware and software. There was a recent a report that was put out by Intel and Microsoft that called it soft PLC. And what they did there is they took the idea of there's a PLC runtime, that's software, and hardware, and you can separate those. And the idea of separating those can provide more advantages in how you can evolve a system moving forward, the openness, and really the flexibility that can help in operations, but can also help in supply chain challenges like we're facing today, and being able to get a hardware piece that maybe you can't get today even though you've standardized on a particular runtime. And I know SESMII is looking at doing work in this area as well and focusing in other areas as well. So there's a lot moving on in this space, Lou, and this IT/OT convergence is key, and you know, this energy management, I think, is one of those lighthouse applications that looks across various industries.
So, John, we can't keep you out of this technology conversation, but you've got to give us the big question, the why question. So why are these new systems and approaches vital for U.S. smart manufacturing progress and success?
Yeah, so the sort of legacy approach that Ira outlined is the outcome of the third industrial revolution. And I would argue that manufacturers don't do revolutions, right? I mean, we've been talking about Industry 4.0 for 4 years, for 10 years rather.
10 years.
And we've really just started this journey. Manufacturers are slow to adopt because they fundamentally, at the end of the day, have to ship product in safe and high quality manner. And if there's anything that has the risk of disrupting that, that's not going to happen. But so I think we're right now on the cusp of crossing that chasm to understand what you were describing, Ira, as lower cost, lower complexity, and interoperability, which gets away from vendor lock-in and data silos and stovepipe architectures, all of which represents tremendous drag on our ability to implement these data-driven solutions. Smart manufacturing is about digitizing and creating value from your existing assets. And if it's so costly and so complex to do that, the accessibility of these things is going to continue to be a struggle. So we did the analysis to say that up until this point in time, for every dollar of value creation, innovative software for a manufacturer to buy, will take $5 to $6 additional dollars to implement it. Well, that's just a huge barrier. What might cost $10,000 to buy a great smart manufacturing solution will cost $60,000 to implement. So the return on investment just all of a sudden went from here to maybe never. or at least for some manufacturers, that's never. So it all comes back down to agility, interoperability, and it's working with great organizations like Phoenix Contact that have that vision for openness and interoperability and collaboration to solve these big problems, and not sort of make our differentiation a point of sort of generic proprietary networks or information models or structures, right? It's the opportunity for the future, for a more competitive manufacturing future here in the U.S. to work as an ecosystem to solve these problems and to eliminate that legacy, sort of heavy, ponderous legacy of Industry 3.0.
So let's expand out again, back to the bigger societal and economic picture when it comes to the United States of America, because you read about it fairly consistently, lots of manufacturing jobs going unfilled. In our country's history, work in manufacturing was considered a vehicle for upward social mobility. However, a fair portion of the existing or maybe even the developing workforce probably have some views of U.S. manufacturing as unattractive. So, what it is, what it's been through over the past several decades and the like. So, John, how can smart manufacturing change the image of manufacturing and catch on and be interesting to workers? And how about those ready to enter the workforce?
Yeah, I think that's another really important question. I was in a room full of manufacturers a little while back, and I asked them, how many of you have invited your local high schools or educational academic institution into your plants? And only a couple of them had done that. Each of these manufacturers would, with no exception, represent a dramatic sort of leap forward from the old days where the plant floor was kind of a dirty and gritty environment and really unappealing. And so that may be really basic, but the idea that we can engage as manufacturers, we have to be a little more open and collaborative to open up our shop floors to inspire a sixth grade student or a high school student to say, this is an honorable and dignified and cool profession, right? So I think at a base level, anybody can start there, and I think it's really, really important for us to do that. Other great manufacturing regions around the world, including most of Western Europe, have done a much better job at that than we have here in America, North America more broadly. So I think that's key, and I think the other part of this is, as Dave, you just outlined a few minutes ago, when we democratize access to data, when we put data in the hands of the operator to say, hey, I'm competing with Fred over there or Mary over there, and I've got another 2 jobs per hour to put through my machine until I catch up to them. How can I do that without jeopardizing quality and security and all those important things, right? Just using smart technologies, the idea of engaging the workforce to say, this isn't going to take my job away. This isn't a risk of undermining my livelihood over here. All of these are just basic things that I think we have to be much, much more intentional about. But I think smart manufacturing is an enabler because it's, no matter what it means under the hood from a technology deployment standpoint, it's about engaging the work. It's the catalyst that allows the leadership to engage the workforce and say, we're going to improve, we're going to become more competitive, we're going to invest more in our U.S. operations, we're going to make sure that your job is here for tomorrow and for the next generation. And that's really something we have to get better at.
I like to pile on again. So John said it great. I want to remind everybody it's just like the energy puzzle and just like the automation puzzle that the small and medium manufacturer doesn't know what they don't know. You highlighted it, Lou. The image of manufacturing is dirty and hard work and low pay and a lot of repetitive tasks, and people just want to avoid it. So we have an image issue. There's part reality and part not, right? So the part reality is for those manufacturers who haven't embraced smarter techniques, who still are living an old model, then their image is true. It's not a great place to work. The great news, the optimists in this room, we see it happening. We see people transforming their manufacturing environments to be at least partially automated or a little more automated or a little smarter. And when that happens, it becomes magical for the worker and they love their job. So back to my example of the cobots where we took out non-value added tasks that those workers didn't want to do anyway. Now what do those workers become? Dave's got many of them. He trains them and funds this initiative to create what we call mechatronics apprentices. People that operate the machine, they do repair and maintenance on the machine, they fill the machine, they run the jobs, and they feel like they're managing a process, they're managing an automation cell. And that's the factory worker of the future. So we do have a responsibility, all of us, to make our factories smarter and better. But if we do that, then that image will change. And then I think, if you build it, they will come.
Right.
I don't think we're going to have any trouble getting the workers to come to enjoy their careers in manufacturing because it'll be a place they want to work.
Sure, absolutely. What do you think, Ira? What makes smart manufacturing cool?
Yeah, we discussed a lot of things here that make it cool. And I do think it's really important from the small to mid-size to really consider this because, let's face it, the big guys are considering it. So to remain competitive in this ever-growing landscape, it's critical that everything evolves here. But what makes it cool? I really look at where the automation space was and is, and where it's evolving to. And okay, yes, there's a lot of different ways to program, and we have standard ways of controlling PLCs and these kinds of things. But we can really evolve past those standard ways. And the person going through school, I have 4 kids, right? And I think about where they are in programming and these kind of things compared to where I was and where my parents were at that age, and they're light years ahead. So being able to apply things like Python and C and these high-level languages to a factory floor environment and actually make things happen on the factory floor is really cool, right? And not just doing it in the standard ways. I'm not saying that's the way that everything's going tomorrow, but I'm saying there is a host of talent that's coming through that has great programming capabilities, great capabilities to really make cells and make operations work in a different way than was done in the past. And having that new look, having that new way of thinking, having that new energy to really approach the manufacturing space, I think is really cool. And so I got to do a bit of a shameless plug here for PLC Next, because when I think about cool, when I think about manufacturing, PLC Next as a platform, as a technology, I think is so interesting because it's not locked up behind closed doors, lock and key. There is a community that's out there that you have direct access to developers if you have questions. It's open in that way. There's PLC Next technology that's on a hardware set that allows you to do things in a fixed way as a PLC and gives you enhanced functionality. But it's open in the same sense that if you want to use different softwares, whether it be Codesys or something from Schneider's EcoStrux's platform, you can run those on that same hardware. You're not locked into a single thing. It's a different way of thinking about a common classic problem, and it really opens up a ton of opportunity for the future. You add into that things like HTML5 visualization, which is a fancy way of saying it works on your cell phone for visualization or on a nice HMI. There's a host of different ways you can do things. And that, coupled with the IT/OT integration, that data person that you were speaking about, that bridges that gap, this is a really interesting space. And I think one of the major growth areas for a lot of companies, for the industry as a whole. And how do you take data, make it information, transport it securely to improve operations? There's a lot going on in this space, and I'm personally really excited about it. And I think what's happening here as a whole is just really cool in general.
Yeah, excellent. So thank you, Ira. And thank you, Dave. And thank you, Jack. And thank you, John. This has been an extraordinary conversation. I think it lived up to my promise of being really in-depth and interesting for everybody. So many different perspectives, so many different levels of perspective and experience. Really appreciate it. Thank you, gentlemen.
You're welcome.
Thank you, everyone, for joining our panel, and we hope you enjoyed it. Take care now. Bye-bye.
Thanks.
Take care.